And I don't give students any assignment in the first month, so definitely you can join the Labor Day without worrying about our class. But next month you will definitely have some assignments. Okay, so today let's continue our study of forecasting. Let's briefly review what we have learned so far for the technicals of forecasting. The first method we have learned is called what method? Naive method, naive forecast, right? So remember this example, if we consider trend, there's an increase trend here with naive method, then what is the forecast for period 3? Anybody remember that? What is the forecast for period 3? Naive method with trend.
48.
48, right? It's 44 is the base of last period's actual value plus the trend, which is 44 minus 4 is 4 increase trend, so that's 48. So that's the first error mathematical model we have learned for forecast. And later we learn a simple moving average method. We'll just take the average of previous n time period. And weighted moving average is a little bit complex. That's you have to consider weights, right? Consider different weights for different time period. As we explained, okay, the weights usually, right? The nearest period has the highest weights, while the far away period has the lower weights. Then we go through this example, right? Giving the weights for different time period, and we need to calculate the forecast period 6. Well, in this example, you can see period 1's data is useless. The reason is that, okay, we don't need period 1, right? Because only 4 weights are assigned to the last 4 time period, and period 1 is useless. Well, I like this example because, as we have discussed, in reality, most likely you will have a lot of redundant data. Well, your manager can throw you like 2 years data sets. Will you use all of them? Maybe you can, but if it's not relevant, you shouldn't include in your formula, right? Then you choose, okay, how many periods you want to use, what data are reliable or trustable, and then choose the method like, okay, let's say moving average 4 period. That's all the data you need, right? 2, 3, 4, 5. That's all the data. Okay, question, comment so far before we begin the new contents? No? All right, so we begin with this model in this class. It's called exponential smoothing method. So it still belongs to the family of time series model. Right? It still uses past data to forecast the future data. That's the time series model. Right? So it's a weighted average method, which is based on previous forecast plus a percentage of the forecast error. We're very familiar with forecast error, which is A minus F, actual minus forecast. That's forecast error, right? So the FT is forecast for this time period T. T can be 1, 2, 3, 4, any time period, right? When we talk about period, always remember it can be daily, weekly, monthly, quarterly, yearly. It can be any period, right? So Ft minus 1 is the forecast for the previous period, T minus 1. Alpha is the smoothing constant, and the At minus 1 is actual demand or sales from previous period. Okay, now I want to ask you a question. Here, they say At minus 1 is actual demand or sales from previous period. What's the difference between these two English words? Demand and sales. Are they the same or they are different? My question is demand and sales.
They're different.
Any difference? What kind of difference they have? Demand and sales. Anybody can tell us? Nobody?
Isn't demand like how much people want and the sales how many you actually sell?
Very good, Gerard. Okay. Gerard said okay, demand is truly how many units people want to get. But sales is actual how many people get or customer get, right? Okay, then if we go to math way, and this demand and the sales, I will tell you they have some relations. right? It's either great, equal, or less. Which symbol you are put here? Great, equal, or less?
Generally greater.
Yes. Strictly speaking, it's greater or equal to. Right? Okay, first let's think about simple case. When will be demand equal to sales? In which situation we have demand the same as our sales? For most situation. Right? Hard for you to explain. And then I will ask that way. In what situations demand is greater than sales? Shortage. Inventory shortage. Very good. So when you don't have enough inventory, you will have end up with sales less than demand, right? If you have enough inventory, sales is equal to demand. Right? So most likely we prefer this scenario equal, but we understand sometimes it's great, so it's great or equal to. That's a relationship. Okay, then come back to here. AT minus 1 is actual demand or sales from previous period. Ideally, we want is A is actual demand or actual sales. Which one we should prefer?
Actual sales.
Actual sales.
Actual sales? Alan, Kayla? Do you guys agree with them? We prefer actual sales rather than actual demand?
Yeah.
James? The first row? Everybody agree we prefer actual demand, actual sales than actual demand? Any different opinion? No?
It depends.
We have only 19 students today. That should be 30 all of us anyway. Independent?
It depends.
It depends.
Yeah, I think demand. You might want actual demand.
Okay, so you prefer demand. Okay. Okay, before I talk about my idea, let's first ask you guys a question. What is our purpose of forecast? Do we want to forecast the sales or do we want to forecast the demand?
Forecasted demand.
Right? Why we don't want to forecast sales?
You don't know if they're gonna buy it or not, right?
That's demand, silly. Yeah. Sales is, I can tell you, Charles always has very silly examples, like I'm a perfect weatherman for like seconds weather. I can tell you a silly example. I can make 100% accurate sales forecasting. Very simple. I hold nothing. I hold no ice cream, so my sales for ice cream is always 0. Perfect. Right? It's easy. Why don't we finish this class? Okay, it's forecast for sales. Tell your method, right? Tell your manager, 100% accurate. We are not interested in that, right? Or even you tell me, okay, I only have 100 units of ice cream in Walmart, most likely we'll sell all of them. So I can forecast the next week Walmart's whole ice cream sales, only 100, because we don't only have 100 on hand. Because of hurricane, whatever reason. Are we interested in that? No, we're not interested in that. Even we sell 100, want to know, okay, how many customers we disappoint. That's very important, right? We prepare in the future. So what we are really interested in is demand, because demand is objective thing. It's not determined by us, but sales. You think about the big constraint is our inventory level. So sales is related to our decision, inventory. So it's not objective. So we shouldn't focus on the forecast of sales. On the other hand, we should forecast demand. Then, for the question back, now do you prefer to A is actual demand or actual sales? Actual demand. Because apple to apple, right? If you only have previous actual sales data, you think about it, if you experience shortage for several weeks, their sales data is very different with demand data, with true demand. Well, then you say, oh, I only sell every week, I only sell 100 ice creams. Then easy, like you method. Next week still 100. No, that's not the true demand. If you can order 200, you can sell all of them. Right? You need to know the true demand, then you can make the forecast of demand. In the ideal world, I said. Now here is the why you say demand over sales. Yeah, we know that. We now agree, right? We prefer demand. We prefer historical demand data to forecast future demand data. Now, why you say demand or sales? Why just say demand? Why?
You wanted to test us.
What?
You wanted to test us out.
You mean I set this trap for you guys? No, it's from textbook. No, I don't set this trap for you. But anyway, I still have this discussion topic in my online session. Ask my online students to talk about what's the difference between sales and demand. Why we should consider difference. The reason is say all is because demand data is not always available. You think about last week, Walmart only sell 100 units of ice cream because of shortage. Do you know the real demand data? You don't know. Maybe you can estimate a little bit, but you have no idea what is the true demand should be like because shortage is shortage. Well, in some company they know, for example, Apple with online sales, you have pre-order. So you pre-order iPhone 7, let's say you pre-order that. Even they can't satisfy the demand in the first week. They know, okay, that's our demand is like 10,000. I only satisfy 5,000. That's a shortage for this time. They know that. But except for online retailer store like Apple, nobody, even you go to Amazon, if you show out of stock, you don't add to the wish list. Do you? You don't add, right? You just switch to some other brand. So except for high-end brand, they know exactly unrealized demand for grocery stores, for shopping malls, for most things we see, sales of products or service. We don't know the unrealized demand if we experience shortage. It's clear? Agree with me? We don't know that because you go to Walmart, you can't find the yogurt. Do you tell anybody why I don't have yogurt? You don't tell them, right? It's waste your time. You just go to the Food Lion whatever to find it, right? Or choose a different product. So that's no way Walmart, they know that, okay, there's some unrealized demand. How many? They don't know. So in reality, if we don't have actual sales, actual demand data previously, okay, like last period, there's a shortage of our ice cream, then the only thing we can use is sales. Hopefully, the shortage happens less frequently, then we know that sales most likely is equal to demand, most likely. If you know some time period like last week, we have a lot of shortage. Well, it's most like only Sunday afternoon we have shortage, right? It's the half of the week we have shortage. Then you should be very careful to use this sales data to make a forecast because it's biased, right? But in reality, if your sales data is very similar to the demand, you know you don't experience big shortage, then you can use sales data. Use actual demand data many times it's really hard to get. Now, okay, everybody writes this formula. Then we will have the example. So Ft equal to Ft minus 1 plus the smoothing constants alpha, At minus 1 minus Ft minus 1. That's the formula of exponential smoothing method. Now here's the example. Suppose the previous time period forecast was 42 units and actual demand was 40 units. Okay. And alpha equal to 0.1. What is the forecast of this period by using the exponential smoothing method? So this period is Ft, right? That's what we want to forecast, Ft. Now we have to figure out the value of all these three symbols. Well, the first thing is very simple. What is alpha for this example? Alpha equal to what? 0.1. It's already given, right? That's pretty simple. Now look at that. Ft minus 1. Anybody figure out what is Ft minus 1?
42.
42. Very good. I still wait for other students. You guys figure out why is 42? Could you explain to us why is 42?
States the previous forecast was 42 units.
Yeah, it's too easy to explain, right? Because the first sentence, right? The previous forecast, which is previous, is the time period before time t, period t is t minus 1. So Ft minus 1 is 42. What about At minus 1? Do we know that? At minus 1? 40, right? It's previous period actual demand. Okay, now I'll give you guys 2 minutes. Finish this question to calculate the forecast for this time period. You guys are good students. You don't leave early for a long weekend. Do you have any plan for traveling during the long weekend? No? Very simple example. No, it's ready. Mike, right? So, how do you get this?
Modify count 1 by 2.
Oh, okay. So you multiply and then minus. Yeah, that's. Oh, okay. I see your point. I see your point. Okay. Okay, that's good. Because usually I will first. No. Yeah, but if you prefer that, that's totally fine. Yeah, that's 41.2 or 0.8. So it's, that should be the 42. Good. It's really easy. It's really easy, right? We're back to elementary school. Well, my daughter just entered the kindergarten this week, and my wife, she's like kind of tiger mom. Really, not really, but she try to know what my daughter learned every day at kindergarten first week. She pushed me to ask the teacher today. Say, okay, you ask the teacher because it's always me to send my daughter to school. How's her performance in math class in the first week? So when you school, I understand as a teacher. I understand it's first week is warm up, right? You in here is warm up. So I asked the teacher, say, okay, how's Priscilla's performance in math class in the first week? Teacher is shocked. I say, I don't really teach math in this first week. I teach discipline, follow the instructions, something like that. That's understandable, right? So. But anyway, it's very, very interesting. That's okay. That's always the gap between parents' expectation and what real school can teach. Do you get that?
I don't know, that's what I got. Like minus 42.
Yes.
Negative 2.
Negative 2. That's 0.1 times
Negative 2. Okay, well, I had 42.
Yeah. You guys got that?
Okay.
Why still 42? Or 41 points? Okay.
Yeah.
That's right. That's right. Okay, let's do that together. I need a volunteer to tell us how to solve this problem.
Just input all the numbers.
Any volunteer? Have so many students finish this one. Nobody wants to talk? Kayla, I like you.
Already.
You always tell me.
Do what's in the parentheses first. So 40 minus 42 equals negative 2.
Okay, so you want to come over. Okay, I will do that. So
No.
40 minus 42, right? Is forecast error times
0.1.
0.1, which is the smoothing.
And then plus the 42.
42, which is forecast. Then what is your final result?
41.8.
41.8. It's clear for everyone? I don't know, understand most people already get that. So you can see this express smoothing method is pretty simple, right? It's you just use the previous period forecast and the actual. Well, it's a little bit different with Layu method because Layu method we only use the actual previous period. But now we are not just use the actual, we also capture the forecast error. We'll see, we adjust a little bit, right? So we'll see our performance of last period. Then, this is forecast error. Then we'll adjust our forecasting for last period by the forecast error. It depends on this constant. Alpha usually is between 0 and 1. Usually it's between 0 and 1. I should say that. So alpha should be in this range. Okay. That's negative like 1.5. That's probably something wrong. Okay, that's the explain smoothing method. No question, right? Yeah. Next one. Okay, next one is the one probably we have caused most time of this class just today. Right? Okay, next one we're talking about is a really wide used method. It's called the linear trend method. So linear trend method is here. If you see the historical data, something like this. You see here, if you plot the historical data, and it's like this, it's like a straight line, then you should consider linear trend method. So, if we see a simple data plot, review the existence and nature of trend. What is the trend now here? Increase trend or decrease trend? This one.
Increasing.
Increase trend, right? Very good, Alan. So linear trend equation, if we plot data, okay, we find increase or decrease trend, then we want to use this method, linear trend equation. Then forecast ft equal to a plus bt. Right? That's the first thing you guys need to write this down. A plus bt. Well, ft is forecast, a is the intercept, which is the value of ft at t equal to 0. You must understand the intercept, right? B is slope. Slope will determine whether the line is pre-horizontal or vertical. T is specific number of time period. 1, 2, 3, 4, 5. Okay, here is the formula of slope and intercept. You guys already learn this formula when you are in business statistics class. Anybody remember you have learned that before? Anybody?
Is that like y equals mx plus
Yes,
c?
yes, yes. So it's like y equal to, it's not t, right? In the statistics it's x, right? Y equal to a plus bx. How we estimate a and b. But it's similar here. Okay, now I can write down this formula just in case you need that, but you should also write down that. So the slope is b. It's calculated in this way. I will explain step by step. Okay. So that's the formula to calculate the slope, which is b, right? A plus bt. Okay. Anybody have question about this symbol, summation symbol? Yeah. Anybody? Everybody understand? The sigma, big sigma means summation. So it's summation ty, which means t from time period y, 1, y t equal to 1, and then what is the actual demand for this period? Multiply together. Time period 2, then t equal to 2. What is the actual demand? Y. Multiply together. Here it's we sum t together, right, from 1, 2 until 10, and sum the actual demand together. Well, this term means, okay, first you calculate t square for each time period. 1 square, 2 square, 3 square. You add them together. And the last one means you sum t together, 1 plus 2 plus 3 plus 4 until 10, together and then square. Oh, that's the formula is complex, but don't worry, we'll have time to go through example, then you'll know how to use this formula. And then once you get B, you can calculate A in this way, or I would prefer the second formula, A equal to Y bar minus BT bar. Well, Y bar is the average of the previous demand, or the period. T bar is average of time period. So if you equal T from 1 to 10, that's 1 plus 2 plus 3 until plus 10 divided by 10. That's T bar. Clear? T bar, Y bar means the average, means the mean. I will prepare like at least 15 minutes for you guys to do this example. Let's do that together, okay? So formula are here. Formula here. The first thing before we jump to the linear trend method is always remember, I don't require you to do that now. Here like plot the data, but you should do that every time when you try use the linear trend method, like I did here. If the data show the linear trend, then use linear trend. Otherwise, you should consider other method. But this example is okay. You don't have to plot that because it is linear trend. Cell phone sales for California-based firm over the last 10 weeks are shown in the table below. Plot the data. Waive this requirement for you guys. You don't need to plot data. And check whether it's a linear trend would be appropriate. I can tell you it is appropriate. Then determine the equation of a trend line and predict sales for weeks 11 and 12. That means our objective is F11 and F12. So that's what we want to get. Okay, my suggestion. Okay, no, you don't have to follow my suggestion to begin this problem, but that's my suggestion. So you have week, which means T. Clear? Week means T, right? This time period. And you have sales. Which symbol is correspond to sales? In this formula, which symbol? Y. Good. Okay. Then you write down this 1, 2, 3, something like that, like 700, 724, 720. Okay. I would suggest you to add some additional column than these two. The first one definitely suggests you to add is t squared. The reason is that you think about here, right? You still need to calculate the t squared for each time period and then add them together. It will work comfortable for you to first calculate this column one by one, so which means 1, 4, 9, and so on, t squared. And then it will make you easy that when you sum them together later. Another column I would suggest you guys to add or calculate first is t times y. The reason is here. The first term in the numerator, when you plug in the formula, it requires you sum together each time period t times y. So the first one, what is ty? The first period. Anybody can tell me? 700. What's about second period?
1448.
Good. The third period is 2160, and so on. So after you guess this, I think it's pretty straightforward. Just be careful to plug all the number into this formula. Okay, last question. What is n here in this problem? What is the value of n? It's 10. Exactly. N is how many previous data we have. How many periods? We have 10 previous periods of data. So n equal to 10. Now I think you have all the information you need and try to solve this problem. Okay? Give you guys enough time for sure. If let's read the whole class, the rest of the whole class. Try to figure out by yourself. So you use the. I didn't see the detail for calculation. In the homework, you have to show me the details of calculation.
Okay.
Yes. Yeah, you can't just give me the. This is the slope, right? Oh no, the intercepts.
Yeah, the intercept.
Yeah, intercepts. Yeah, but because I can't check whether it's correct or not.
I used the second formula, the average of y minus v average t.
Yeah, that's the slope. That's A, right? That's for calculating A, right? That's one, right? But the key point is this one. How do you guess this number?
This is the average of y.
Mm-hmm.
Uh,
Yes, average y. What's my question is, okay, this I see.
I used to
Slope,
formula.
so the slope is here.
Yeah.
What, how do you guess this one?
I did 775 minus 700, which is 75, and then I did that over 10 minus 1 is 9, so 75 divided by 9.
Do you follow the formula here? Do you use the formula here?
No, I used the basic slope formula.
You don't use this formula? How can you guess the b?
I used the basic slope formula.
Okay, basic swap formula. What's that formula?
Basically rise over run. So I did 75 divided by 9.
75? What is 75? You mean last one? 775?
Yeah, I used the first point and the last point, right? So this, I would do,
You can write it down, but I think it's not correct. So you divide by 10. No, Mike, this is not the way we should do. The formula here, summation, means we have to sum them together. So which means, for example, ty, summation ty means, okay, 700, which is the weak one, 1 times 700, ty is what, 700. Second is 2 times 724, which is 1448. So add this last column together, that's summation ty. 700 plus 1448, 2160. That's this two. Yeah, you cannot jump to. I don't understand how you get this formula, but it's well, you think about it. Okay, if we use this formula, you ignore all the middle points. You only consider beginning points, period 1, and period time, right?
okay.
Then what's happened on period 2 to period 9 doesn't change anything, but it matters. All data points matters when we create this linear trend equation. All right,
Okay.
just follow the formula, should be fine. But I like your critical thinking, development method. You think makes sense. Sure. Take your time. Put the calculator on. Everybody use iPhone. It's easy to identify iPhone by just look at the calculator, right? Will you guys buy iPhone 7? Yeah? So expensive. Okay. So, let's be explained. Go to the whole class. Okay, I can see many students have finished this table to calculate t squared and ty, and then some of you guys stuck here after you finish the table and don't know, okay, what should we do? What should we do if we finish the table? To plug in to calculate the slope b. That's the next step. Right? Okay, the slope b we calculate this way, and so we have to sum together ty, which means 700 plus 1448 plus 2160 until the period 10. Add them together, period 10 as well as period 10, so 775, which is 7750. So add this 10 number together, that's your summation ty. You multiply by n, which is 10. That's finish your first term. It's clear, everybody? Clear? So so when you finish this table, the thing you should do is that for the last row, you should add another row called summation. Then this together is summation t, which should be 55. Correct me if I'm wrong, but I'm pretty sure I'm right. So if 55 is the summation, right? And here I don't know, but it is summation y. You need to calculate summation t squared, summation ty. Then it becomes straightforward. Once you get the summation for these 4 columns, then you just plug in summation ty, summation t times summation y, and the t squared summation here. And the summation t first, you get 55 squared. You should be able to calculate the b. Genes?
Reese.
Rings.
Yeah. So do we multiply like the summation of t times the summation of y? Like,
Yeah. Good question. Well, in fact, I understand this question because I have some previous students asking me the same question. So Ring's question is about this, the second term, right? That's the question, right? Summation t, summation y.
yeah. It's
Yeah, right? So always remember, summation is the same as additive. Add them together. So multiply and additive, okay, they are different, right? Multiply has a higher priority than additive. But here when we have summation, that means add the brackets here.
So
You first sum t.
so yeah, we're supposed to multiply.
Yes.
Okay.
You multiply only the summation, right? If you write it, if you just write t1 plus t2 times y1 plus y2, then it's different. But if you have summation, you would think about, okay, this is under the protection. So we sum them together and then multiply.
7.7.
Clear? Take your time. Sure. More than happy to do that. Done? Is that your slow?
A
This is
and this is
Actually, unfortunately, I don't think it's correct. The reason is that you think about you can think as A. I don't know the answer. I didn't check the text, but I can tell you directly it's not correct. So A is the expected sales for period 0. That's the A. You can see, or even we don't know the period 0, but it should be like around 700, a little bit less than 700, right? If you see this number, you know it's off the charts. Okay.
Yeah, y would be that
We'll check.
times 10, which is n equals 10.
Oh, so wouldn't it be 50?
No, because that's the sum of t.
Question? Everything's good?
N is the number of periods, which is 10 periods.
By the way, we already have a tutor in this class, but I don't think you need him now, but I will post his contact information next week. Then when you are doing homework, if you have a question, you can ask him. His name is Michael. Another Michael. This looks correct for me. Have you finished the calculation though? Or not? Okay. Looks correct for me.
I can't have it be on 2 pages.
That's okay.
So, he's gonna equal the sum of A and
10 summation ty. That's good. Joseph, you missed some classes. You missed some classes. Monday. Okay. Well, you know. You also miss Wednesday, right? Okay. B is not correct.
B is not correct.
Not correct. The easy way, Dion, you're very smart. So I will tell you the easy way to check whether it's roughly correct is that B is slow. That means it's the average difference between each period, right? When we increase by 1, t by 1, that means we increase this B. Then you can look at this time period, right? It's increased from 700 to 775 in 9 period different, right? Time minus 1. So you take the average, so it's 75 divided by 9, which means it's like around 8. Yeah, right? So if you look at this number, I think it's off charts.
Okay.
Something should be around 8. Okay, clear? Yes, sir. Probably not, but very close.
Okay.
Very close. Yeah, I know it's pretty tedious, but just be careful. We have enough time to do that and try to eat again to see what. No, that is too big for sure. Yeah. Let's see what's your problem. Okay, 385. You didn't mind the first one is n times summation t squared. You didn't multiply 10 also. I'm sure whether you have multiplied 10 by here.
Yeah, I did. Okay.
So multiply by
This was 385.
Got it? You ready?
What do you put t squared?
You got it?
Summation?
Very good. I believe that.
You're making me second guess now.
Huh? Yeah. Well, I didn't check the answer, but I have this impression that mine still have the same answer. I believe it's correct.
Almost 76.
I still get
Yeah, 385.
7.509 something, but we run up to something.
I just rounded it.
Yes.
Yeah, and also 12. Okay, I have seen more and more still have finished this question. Very close this time. That's
That's where I messed up.
But let's double check.
It's like 7's wrong.
This number is not correct for me. 4133. I see mine is student, but you can check it again. And also, 81, I'm not sure whether it's correct. You can see that, you can check, maybe it's correct.
You still got one more class?
Yeah, the slope should be.
Get your paper done.
7.51.
Yeah.
7.09.
Right at 14.
I was,
Yeah, you get that. Good job, Adam. You told me your math is extra. It's good.
Once I know how to plug in the numbers, it's okay, but I was like everybody else, what do I do now?
yeah, I just thought that too.
Yep.
Yeah, because
So the
just
top
for
of
the
the
form
thing,
to
after we've been.
you first need to sum them together. Each
Oh my god.
one plus 2.
And I did.
That's summation t. and also sum them together. That's and then you plug in the formula. B to n times that's the formulation you use.
So what you got?
That's your scope as well.
I'm sitting there trying to
Where's my initials? Just like this?
Oh, sorry.
Oh.
And
How's that
also,
run?
I would suggest you keep 2 decimals accuracy, so it's 7.51. Yeah, because it's helpful. Okay. I have C. Many students have finished that. Who want to share your calculation detail with us? Anybody? I see many of you have finished. You? Okay, great. What's your name?
Dante. Dante.
Downson?
Dante. Dante.
How do you spell that?
D-O-N-T-E.
D-O-N-T.
N-T-E.
Danton. Okay. Could you tell us how to do that?
I plugged in 10 for N.
Okay, great. Summation Ty.
41,358.
Everybody gets the same answer here? You get the same answer? Okay. Minus summation T.
55
Very good.
times
Times?
7,407.
Everybody gets the same number here? That's summation Y. Great. Divided by Danton.
Put 10 again.
10.
Times 385.
385. I believe most students get the correct here. Last one. Minus
55 squared.
square. Okay. If you get all the number correct here, and I believe most likely you will get the correct speed. But just when you so you can see the big step is here to calculate this summation. Be very careful. If summation is right, just like Danton has done, just plug them in. So what your results will be?
7.51.
7.509, but you can round up to 7.51. In the homework and the exam, I suggest you guys to keep 2 decimals accuracy. That's just my requirement. So you just round up 7.509 to round up to 7.51. It's enough. You want to keep more than 2, that's also fine for me. But at least 2 decimals, all right? Then what is the next step? A.
A.
Okay, yeah. That was a full memory.
7,407. Or 7,407.
How do you guys?
Isn't it?
Simple mix calculation.
It's sum of what?
You do the average.
Oh, I did the other one. Never mind.
Okay. Anybody did that?
Yeah.
Okay. Can you tell me?
It's 740.7 minus 7.51
Mm-hmm.
times 5.5.
Then what you get?
This is the one.
699.39.
Okay, then we get this formula, right? So it's Ft equal to 699.5, right? Or 3?
It's 39.
Or 3? 39.
Yeah.
Okay, and let's write down 4. Right? So plus 7.51t. Then anybody gets the results for forecast of week 11 and week 12? Anyone? Week 11, F11 equal to what?
782.
There's so many of you guys already finished that. Dylan?
782.
782. What about F12?
789.51. That's what I got.
And you plug in like 11 for T, and
Yes.
F equals A.
Yeah, A and B is already given. You just plug a T equal to 11 and T equal to 12 into the formula. You get the forecast.
Okay.
Okay, it's clear?
Yeah, I got it.
All right. Perfect. Finish this example. I hope everybody, at least most of you guys get the idea. Let me know if you have any questions. Enjoy your long weekend. We'll see you guys on Wednesday.